Hello friends, now we are going to start my new video which is on concave lens. Now this video is just the third video of the lenses topic that we are covering these days, and in this video we are, as the title suggests, learning what are convex lenses and how they work. So first of all, concave lenses look like this. So basically this is a regular lens, I mean concave lens. So as the name suggests, concave, the most of the lens is like a cave. It's bent inwards. So because of this property, it's concave. And also the other properties are that the ends are wider than the middle section, which is the thinnest, and again the end is the widest. So this property is the main property which tells that it is a concave lens or a convex. So basically, and why I am telling this, it is a convex or convex, concave or convex, because there are plano-concave lens, plano-convex lens, concavo-convex, convexo-concave. So these lenses are a little bit difficult to get out that if they are a convex lens or concave lens. So this property clears all the doubts. So now we are seeing that what is a concave lens, how it looks. Basically, a concave lens is a lens which looks like the inner portion of a sphere and is bent inwards and is extended outwards and at the edges. So now we will learn how it works. So let me just make a new diagram which is much more clear. So now this is a concave lens, basic one, not plano-convex, concave or concavo-convex, convexo-concave. I am not going into deeper detail, just the basics. So I am taking a center line, the plane is the center as it was in the convex lens video. So this is the center line, the median. So now if there is an object, this is the object, not an infinite. So there are not two rays, but it is an object. I will take an example of an arrow like this. So a concave lens suggests that when a light enters the lens, this is the ray of light coming or reflecting from the top of the object. So when it enters, it bends outwards a little, and when it reaches this other edge of the concave lens, it again bends and is diverging. It is just moving on and seeing goes further below. And another theory is that the below portion like this, the light coming from here, the bottom of the just moves straight on. It doesn't bend or anything. It just goes on and on and on. So it is going on and on. And now the light from top of the second ray is going from here through the center. I mean towards the central point, and just move straight on. It also doesn't bend. So now where will the image form? So if you can see that it is not meeting anywhere. These rays are not meeting anywhere. So we can see that say that right now that the image is not forming. But that's not the real thing. We can trace these light rays backwards. Now the real object is like this. It is here. Whereas when we trace this light behind into here, we can see that it is meeting at a point here. So we can say that the object was here, but actually what we saw made the object see here. So this says that when an object is seen through an concave lens, it appears uh, smaller. It is smaller in size and much closer to the lens than it was. So we can say that this point is the focus of the. So we can say that this is the virtual image. So a virtual image is an image which is not in the real form, which is not real at all, and it cannot be formed on a screen. If my hand is a screen, the virtual image is not forming on the screen. It is forming behind it, behind the lens, and it can't be seen. So that's why it's an important lens. So here you can see that the image is small in size. It is much closer, and also this lens is very important as we see, because it is used in many things. Like, have you ever seen a peephole in a door? You can see through it a large area, whereas it is just a small hole. It is like this, and the door is this big. Whereas we can see all the area behind the door from this tiny hole. How is that possible? Because it is a concave lens, and as I told, it covers a large area and makes it in a virtual form, a virtual image which is much smaller than it. So this means that if a man is standing like here, we can see the whole picture of that person and his surroundings like this small. We can barely see it. But when our eye is just in front of it, like this close, we can see the whole person, because the light from his head to toe is coming here and is erect. It is not inverted. So this also says that it is erect. The image form is erect. So virtual image is mostly always erect. And erect means that it is upwards, straight, not downwards. So these are basically all the points, and I also told its uses. So here we can say that concave lens is complete. And basically the concave lens is very easier and much more easier than convex lens and other lenses, because it has very few properties and it's just straightforward. The rays never meet. Now I'm going to show two parallel rays. So like just rays. So here is again an concave lens and its center. Now if we take two parallel rays coming like this, they are moving towards the lens and are parallel to the center. So basically these rays are moving parallel to the center line, and as I told earlier, it diverges. That's why it is called a diverging lens. Also a point, a diverging lens. So a diverging lens, as its name suggests, it diverges the lights. Simple. Now, just the rules that we did in the past. This object is infinitely like stars. Because stars light is very far, we take it as infinite. That was an object which was close. But this, it is infinite and two parallel rays. All the rays here are parallel. So, for simplicity, we are just taking two rays up and down. So, as I said, the light enters, it just bends outwards a little bit, and then it again bends when it comes here, more outwards and moves out. Here the same happens. Bends a little bit upwards, then move, and this makes it look so. It doesn't look. You can't see it because it is converging and concave lens will not form a real image. Now we trace it back here and we can find that this point is the focus or the focus on the other side, and the object, this whole object, is seen like this. So basically that star that was so far behind, just a tiny dot now, and we can see it magnified. I'm not explaining it more detail because it will get more and more confusing the light bit of. Okay, the light is there. The light was just gone because of storms outside. These days there are a lot of storms going. And now, as I said, I'm not going in much more detail. This is the basics, and it is the basics. So this point is the focus. The thing we learned in the past video, as it was a point where the light converged in the converging lens or the convex lens. But here, it is concave and diverging. So the light is forming a virtual image, which is here, and this vice versa. So this is the focus, not here, but here, because there is no focus in this side, like lights that is moving straight on. So basically, I think we are done. I'm just drawing some arrows. So here, as you can see, and another rule that you will be asking, that the center line, it will just move straight on, and if it traces back, it will also meet at the focus. So basically, everything meets as a focus in every lens, just the focus changes. So now we will be learning the types of concave lens. So basically, in the past video, we learned what are the types of convex lens. So like that only, what are the types of concave lens. So now we have learned what are and how a concave lens works. But now we are learning types. So the types of concave. So basically, the first one is plano concave. As it suggests, one side is plane and other side is concave. It looks like something like this. One side is concave, it's hollow towards the inside, and one side is plane. This is called plano concave. So now we learn the second type, which is double concave. Double concave lens. And this is the basic lens that we have studied till now. So we are all studying the double concave lens, as it suggests double concave, one side concave and other side concave too. Now the third type, which is convexo concave, and the first in the previous video was convex convex, and this one is convexo concave. Yes. So now it tells that it's convexo concave. So convexo, so convex one side, and concave. So concave other side. Not the best drawing, but it tells that the sides are wider and the middle part is smaller. So as the property that I first told, which was very important, the sides are always wider and the middle portion is always the thinnest. So this is a convexo concave, because we always take this convex side, this side first, and then this side. So now I hope you understand all these things, and I'm just moving aside and so that you can take a screenshot or just pause the video. So now if you understood all the concepts, it is great, and if you didn't, just write a comment and ask the questions in the comments. And thank you for watching the video, and if you just end up at the end, it's very good because most of the people just leave it at the starting and 5% of you only see it till the end. So I will really appreciate if you see it till the end and just understand the whole concept. And if you don't, if you already know the concept, then it is always better to revise for exams. So please like the video if you like it and subscribe the channel. Thank you.